When making financial decisions, investors usually want to choose the investment that provides the highest interest rate. However, it can sometimes be difficult to compare interest rates if the compounding intervals are different. In that case, we can look for something called the annual percentage yield, or the APY. Now, the APY is useful for allowing us to compare these investments that may have different APRs and different compounding frequencies. Annual percentage yield is sometimes also called the effective rate or the effective annual yield. The APY would tell us what the simple interest rate that would be needed to give the same amount of interest as the compounding rate of the account over the same period of time. So for instance, if I had an account that had a 6% APR but with monthly compounding, it would say, okay, well, this is what the simple interest rate would have to have been on that account. So at the end of the course of, let's say, 1 year, you would have generated the same amount of interest. Now, if the number of compoundings per year is known, so for instance, if it's annual compounding, or quarterly compounding, or monthly compounding, we're going to use this formula for the APY. So the APY is going to equal the parentheses 1 plus r over n raised to the nth power minus 1. So notice in this formula, the APY is actually going to be a percent, but in this formula, it's going to be the percent expressed in decimal form. Little r is the APR of the account. Okay, so this is usually referred to as the APR. Okay, so notice the difference in the abbreviations here. And then n is the number of compounding periods per year. Now, if the account is being compounded continuously, the APY is found by doing e raised to the rth power minus 1, where r is the annual interest rate expressed in its decimal form. So let's see an example of this formula being used. So for an account with an APR of 6%, let's find the APY if the account was being compounded quarterly or if the account was being compounded continuously. Now, in the account being compounded quarterly, that means n is going to equal 4. So we get to use this version of the formula since I have an identifiable value for n. So for part A, we would have that the APY is equal to 1 plus r over n raised to the nth power minus 1. So little r, which is the APR, is 6%. As a decimal, it's 0.06. My value for n in this example is 4, and it'll be raised to the 4th power, and then minus 1. So let's go ahead and key this into our calculator. So I would have parentheses 1 plus 0.06 divided by 4, close the parentheses. I'm going to raise this to the 4th power, and then hit minus 1. Now this minus 1 is not up here in the exponent. If you had wanted it to be in the exponent, I would have had to have parentheses around this whole thing. But since it's not, what this calculator is going to do then is it's going to compute the value of this parenthesed expression, it's going to raise it to the 4th power, and then finally it's going to subtract 1. Right, so this is giving me as a decimal 0.06136. And so on. So this is the APY as a decimal form, so moving this decimal 2 to the right, I would get 6 point, and then maybe we'll round to the nearest hundredth of a percent. So 6.14%. And on these types of problems, they are abbreviated, are notated with APY on the end of it, just to be very clear that this is an APY and not an APR. Let's take a look at how things change if it's going to be compounded continuously. Now under continuous compounding, we're going to use this formula instead. So I have the APY is equal to e to the rth power minus 1. Okay, so in this problem, my APR is 6%. As a decimal, that's 0.06, and then minus 1. Again, notice this minus 1 is not up here in this exponent. Okay, it's down here at this kind of like this base level, so the only thing in my exponent is 0.06. So if I had wanted to grab my exponential right here, so I would have to hit second and then that button to grab this entry. The only thing I want up here in the exponent is 0.06. So at this point in time, I would have to close my parentheses, say I'm finished with this guy's exponent, and then I would have to key in -1. Okay, so now I'm getting 0.06183, and then so on. Moving this decimal over 2 to the right, I would get 6 point, and then again, since that's not 5 or bigger, I'm not going to round that up, so out to 2 decimal places, this would be 6.18% APY. Okay, so comparing between these two accounts, it was maybe a little bit easier to do this because if I was locking in the APR at 6% and I wanted to compare accounts being compounded quarterly versus compounded continuously, since both of these accounts have the same APR, the one that has more compoundings happening in a year is ultimately going to give me a greater return on my investment. Right, that's what we're seeing also down here in the APYs. So this one has a greater annual percentage yield than this one does. What these numbers then mean would be if I were to take my money instead of investing it into, for instance, this one compounded quarterly, if I were to find an account that had a simple interest rate of 6.14%, and I was able to leave my money in that account over the course of a year, I would have generated the same interest that this account would have. So that allows me to compare at the end of 1 year what would be kind of the percentage return on my investment. So let's see another example using this APY formula. Now in this example it says Colonial Savings Bank offered a money market account with an annual percentage yield in APY of 4%. Now the interest on this account was being compounded monthly, so let's find the annual interest rate of this account. Now since this is being compounded monthly, I can use the formula that for APY where I know the number of compoundings. So I would have the APY is equal to 1 plus R over N raised to the nth power and then -1. So substituting in the numbers that I know, the APY in this account is 4%, so 4% as a decimal is 0.04. I would have 1 plus, now the interest rate on this account is not known, so I don't know little r. The account is being compounded monthly, so N is 12. And it'll be raised to the 12th power and then -1. So I want to solve this equation for little r. So the first thing I'm going to do is I'm going to add 1 to both sides to move this. So I would get 1.04 is equal to 1 plus r divided by 12 raised to the 12th power. Now again, this is like that previous problem where I'm trying to solve for this r that's inside of these parentheses being raised to this exponent. So I'm going to have to undo this exponent to free this thing from the parentheses. So I'm going to undo raising something to the 12th power by applying a 12th root. So I'm going to take the 12th root of both sides. Doing so effectively makes this radical simplify with that exponent. So then I will just have this parenthesed expression kind of fall out. So I would have the 12th root of 1.04 is equal to, okay, so those two things undid each other, so I get 1 plus r divided by 12. Now, at this point in time, I want to mention, you cannot go inside these parentheses and, for instance, like subtract the 1 out or multiply both sides by 12. Okay, you can't go inside parentheses and just start pulling pieces out. We had to undo this exponent in order to kind of free this thing so we could start moving pieces around. Okay, so to solve this thing for r then, I'm going to move this 1 to the other side by subtracting it from both sides. So I would have the 12th root of 1.04 and then -1 is equal to r divided by 12. And then finally I'm going to undo dividing by 12 by multiplying by 12. And on this side, because I have more than one term, I need to multiply this entire side by 12. Okay, so ultimately I'm getting that r is going to be equal to 12 times the 12th root of 1.04 and then -1. So this is what I would want to key into my calculator. Alright, so let's pull up the graphing calculator and key that in. So I would want 12 and then parentheses. Now I want my index to also be 12, so I'm going to key that in again, and now I'm going to grab my general radical, which was in math, and then it's going to be option 5, so I'm just going to hit the number 5 to grab it. Underneath this radical I want the number 1.04, Okay, so I don't need parentheses here because that's the only thing I want underneath there. But if you had wanted to introduce the parentheses, you could. Okay. And some calculators may actually already introduce the parentheses. You just have to be sure when you're done with your radical, you close the parentheses. And then outside of the radical, I want -1, and then I will close the parentheses. Right, so this is getting me 0.03928. And then moving the decimal point over 2 spots, that would get me 3.9, and since that's 5 or bigger, I'm going to round that up. So this would be a 3.93% APR. So this is the APR that would needed to be on the account, compounded for 12 months, in order to generate an APY of 4%.